All right, hello, and welcome to our third office hours. This office hour is going to cover questions you have gotten from our Getting Started with Caffe course and hands-on lab. So all our questions will be chat-based as usual. We will not do audio questions, but during this time, Allison Gray will be going over some of the more high-value questions we got during the last week and verbally answer those while we have a group of experts online to help answer your questions over chat. If you have missed the Getting Started Caffe presentation last week, has been recorded as with everything else and is on our Deep Learning course landing page. I'll send a link to that shortly in the chat window. So please go check that out. It has all our old recordings posted there, both downloadable and streamable. It has links to the hands-on lab for the associated classes, as well as past Q&A question and answer logs, so you can go through and look for other questions that have already been answered. So again, if you have questions for this session, please put them into your chat. We will get to them as soon as we can. We typically get quite a few questions at once, so we will, even though it doesn't look like we're seeing them, we are getting them all recorded and trying to get them all answered, and we will broadcast it to everybody so you can see both the question and the answer. All right, with that, Allison, why don't you go ahead and start answering verbally some of the other questions, and we'll start with the chat.
All right, so thanks everybody for coming, and thanks for the introduction, Mark. Before I get started, I just wanted to mention the next two classes that we have, Piano and Torch, and today is going to be a Q&A on Caffe, of course, but if you're interested in learning about the other frameworks like Piano and Torch, then definitely stay tuned and come back and see us next time. And we'll always have office hours for the next ones as well. So you'll have the opportunity to ask questions that maybe you didn't ask during the lesson, or maybe that came up during the hands-on lab when you take them. And all these have hands-on labs, so you'll get not only learn about the frameworks, but then you'll be able to use them. So last week we had the lecture, and my colleague John Barker gave it and talked about Caffe, what Caffe is. And I had a couple questions last week about just how to use Caffe and how you build it. And so I thought I'd take just a couple minutes to just talk about how you get Caffe quickly and just remind people, and even for folks who are new, that Caffe is an open source. It's open source, so you can download it off of GitHub, and you can build it and use it on Linux. You can also use it on Windows. We do get a lot of people asking about Windows. There is an unofficial branch on Windows, so you can use it on Windows, and there is a branch for that. Check that out. Someone specifically asked about Windows Server. I haven't tried it on Windows Server. I don't see there being any issues with Windows Server if it works on Windows, but you'd have to give it a try. There's also a blog somebody wrote a blog about how step-by-step how to build Caffe using Windows and how to get OpenCV and all those dependencies working through Visual Studio 2013. So you can definitely check that out online. We also had a couple questions about using Caffe on a Mac or on any piece of hardware without a GPU, and you can definitely use it. It's just a bit slower, so that's one thing to keep in mind, is that once you start training, it's going to take a lot longer. When you download Caffe, you'll find this makefile.config, and that's where you're going to insert the path to your libraries and so forth, and you'll see a line in there that says CPU only, and you'll uncomment that line, and then you'll comment out cuDNN if it's not commented out, and then you should be good to go. So someone had also asked about CUDA and how that helps and how the GPU helps. So just one thing to think about with the GPU, and when you think about deep learning when you think about Caffe, so Caffe is a convolutional neural network. And let me go to another slide to kind of show you something, to show you a little bit about, I'll jump around a little bit here. So Caffe is a convolutional neural network. It's a framework that allows you to build a custom neural network for your data. And a convolution, you can think of a convolution as a matrix multiplication operation, where you'll have a kernel that essentially slides over your input data, or in this case it will be an image, and it does feature processing. It'll tell you how similar this portion of your input is to your kernel. And that whole process is really parallelizable. And so when you think about how CUDA and the GPU relates to deep learning or convolutional neural network, think about the GPU as your massively parallel processor, and it's really great at parallelizing parallel processes. And so that's where the GPUs and CUDA comes in, and that's where the GPU really shines, and you see the huge advantage. If you have a lot of data, a couple 100,000 images even, and you train or you push your data through your neural network and you use the GPU, you'll see a huge speed up in your processing capabilities. So when I think about CUDA and GPUs and what my advantages are with deep learning, that's what I think about. I think, okay, well, I know this is a parallelizable process and the GPU is a parallel processor. And if you want to kind of just even test things out, like really quickly on your own, there are a couple of simple things you could do. So maybe you just want to get a rough idea for what the benefits are. You can look around online. There's a couple of things. If you go onto Caffe and you look up their hardware configurations, if you go to their GitHub site, you'll see that they've got information on hardware, and then they'll show you what your speed up potential is with training. And we have a slide here that we showed last week that I'll show really quickly that just shows what type of speed up you could potentially get with a Tesla K40 relative to a CPU. And this was using Intel's MKL, and then on the Tesla K40 we had Auto Boost on and ECC off. And this was during training. So, and these times were based on 20 iterations where the input images were 256 by 256, and the batch size was 256. So 256 images were processed at a time in your batch size. And these are the times you can get. So you can get variations in time too. So I think I've seen like changes in my processing time depending on my batch size, and you'll see changes in processing time, like your iteration time, as a function of your input image size too. So those are two parameters that you might want to play with in the future. So one thing I get asked a lot about is how do I optimize my network? What makes the most sense for me? How can I get the biggest speed up? And you start looking at these frameworks and you just think, oh, there's so many parameters and knobs to turn here. Where do I start? So these are just two simple things these are a couple simple things that you could modify on your own and test out with Caffe to see, like, okay, what's the value? How much benefit am I getting out of the GPU? Also, when you go online and look around, if you look at the Caffe's website, you'll see that people will, and if you go in their Google user group, you'll see that a lot of people will post information on the different GPUs they're using and what the training times are. So you'll find interesting things like using the Tesla K40. If you've heard anything about our Digits Dev box, which has 4 Titan X GPUs, you'll see times for that, where people have bought Titan X's and done times and looked at performance. We also have like a Tesla K40, and you'll see training times on that, iteration times on that. And then a lot of people, so if you don't have a GPU system, but maybe you want to just test things out on a GPU and test things out on Linux, or maybe you don't have a machine with Linux and you kind of wanted to test Caffe out on Linux, you could easily launch an instance on SoftLayer, or you could go to AWS and you could launch an Ubuntu instance or get a machine up with Ubuntu, build Caffe on it, and test Caffe out. AWS has Grid K520 cards, and then if you go to SoftLayer, they have a Tesla K80 card that you could use for training too. So there are a lot of options out there for even just testing out for yourself and proving to and seeing for yourself how, like, what type of performance improvements you can get with the GPU. So we had a couple other questions about training data and supervised and unsupervised. So I want to talk about that and kind of go over a little bit of some of the things that you may have seen during the hands-on lab, or if you haven't taken the hands-on lab yet, then this could kind of be like a guide or a preview for you for the hands-on lab. So the hands-on lab is still open, and if you go to the deep learning course website at developer.nvidia.com, deep learning courses, if you go to that website, you'll see a link for the hands-on lab, and you can still access all the hands-on labs that have been posted. And so I wanted to kind of I wanted to go over a little bit what people should expect to see with respect, and go follow along with some of the questions I received. So this one question I got was about, does the data need to be labeled, or can it also do unsupervised training? So you do need to have labeled data, and how you label your data is really important. How you ingest it, how it's ingested into Digit, or into Caffe, so that Caffe knows what input data goes with which category. So I have an example here. So you have two files. You have your training and your validation file, and maybe you'll have a test file. But your training file and your validation file may look a little something like this. It'll be a text file, and what mine look like, mine will have paths to all of my images, and then at the end I'll have my category, and my categories are numbered. So my first category is 0, my second category is 1, and if I had 1,000 categories, it would go down to 1,000. And then I'll have a labels file, which will act like my key, which will tell me, okay, my 0 label is, in this case, my cat, and my 1 label is, in this case, my dog. And I could go on and on. Maybe it's maybe I have trees, maybe I have cars and bicycles, or whatever. And so my labels file will look like this, and my training and validation files will look very similar, except of course my training file will have a lot more data. I have a lot more images in it than my training, or than my validation file. And that was one thing that I think came up a couple times, just how do I ingest the data, and how do I label it. So you do need to do that. Now one thing that I thought I would mention is that also if you wanted to do unsupervised training, so John Barker gave a lesson last week, and he did some interesting work with semi-unsupervised, where he had taken a pre-trained neural network and he pushed images through it and then looked at the feature responses. And even if a trained network maybe wasn't trained to find, like, maybe he had a trained network that was trained to identify like buildings and cars and parks, but he pushed data that it hadn't seen before from categories it hadn't seen, like maybe dogs and cats. And then he extracted some feature extraction and looked at the features, and then used those feature responses to try and categorize the data. And so that, it's not totally unsupervised, but it is one way to use a pre-trained network with untagged data to try and help you tag that data. And there's also some interesting work. Let me paste in a link here that I think might be helpful. So there's also some literature out there where people have published results where they've looked at the features when you're training. Let me go to the next slide so it kind of makes sense, makes a little more sense. Where you look at the trained features and you look at what the responses are. So there was a paper, someone had made this tool, a visualization tool built on top of Caffe, and he had looked at different feature responses and of a trained network for the ImageNet data. And even though there's no category for faces per se, he was looking at responses in the network, and he found that even though there was no category for faces, he could find a similar response with faces. So it was like, even though he didn't have a category, maybe if you extracted a feature or extracted this feature on a regular basis and looked at the response, you could say, okay, maybe that's a face. And I thought that was really interesting. So let me paste this into the chat window so everybody can see it. So here's just one link. I just pasted in the chat window. But I will say that there are other documents out there, and I definitely encourage everybody to look at some of this literature. ICML and even NIPS, they have all sorts, there's a lot of research going on, and there's a lot of really interesting things. And this was a recent paper that I had just skimmed over, and I thought, oh, this is really interesting. Another thing that's really interesting about that is that's built on top of Caffe, and it links to a GitHub site for an open source project so that you can visualize trained networks and visualize features yourself. So that's one thing that you might find interesting. So I'll get back to the convolutional layer stuff and how you configure your network. because someone also asked about, I just mentioned extracting weights and extracting features, but I wanted to show you this slide because it talks about how you configure your network and then how you can visualize things, especially in this hands-on lab. So when you want, before you even get to a trained network, right, if you don't use a pre-trained network, or even if you grab a pre-trained network, you're going to want to know something about the network configuration, and at some point you'll want to configure your own network and do your own training. So here's how a convolutional layer looks, or how you would input a convolutional layer within Caffe to configure your custom network. And notice that you're not doing any programming, right? Just like John had said last week, you're not really doing any programming. This is text-based, and it's readable. So you see a type here that says, okay, this is a convolution type, and you have all your convolution parameters. And I highlighted a couple things. So I circled the number of outputs, so you can decide how many outputs you'll have for that layer. If you're going to do any padding. So when you do a convolution, if you don't do any padding around the perimeter of your image, after your convolution, your input will reduce by 2 times the radius of your convolutional kernel. But if you pad, then your input data will stay the same size when it pushes through the convolution. So this is something to think about. So if anyone took the digits lesson or the digits hands-on lab, you didn't do any padding there. So when you push your data through that network, you notice that your input image reduced in size. But here we're doing padding, so now your input data will stay the same size through this convolutional layer. So that's just two interesting things, 2 things you can think about, and parameters you can vary on your own when you use Caffe or digits on your own for your own data set. And then also defining your kernel size. So if you look at here, I've got a kernel size of 5. That means my weight is 5 pixels by 5 pixels. But you could do different things. If you look at some other popular neural network configurations, such as AlexNet, you'll notice that I think in his first layer, I think his first kernel size is 11 by 11, and then he does, I think it's 7 by 7, and you'd have to take a 7 by 7, I believe. So you can vary this parameter. This is another parameter you can adjust yourself and modify. So I posted this here just to help remind everyone what this looks like. And where this is in Caffe is this will be your prototext file. So you'll see this type of text, and you'll insert this type of text in your train solver prototext file, and that's where you define your neural network. And you'll define it in a text file, and you'll see that you'll have things that look very much like this convolutional layer text here, and you may have multiple layers, so you could have multiple versions of this. And what you would see is your name would change. So maybe your second one might be COM2, and your third one might be COM3. And then depending on where you are in your network, the input, the bottom will change. So if this is at the beginning of my neural network, the data is the bottom. But then for my second convolutional layer, my bottom might be convolution 2. Or if I had a pooling layer, it would be pooling or something like that. And what I have shown here on the right is an image of an example input image, an example of your first layer of weights, and then what your activations might look like. So when you talk about a convolution, for those of you that might not be familiar with convolutions, think about this weight, maybe the first one on the top left. Think about it as a kernel that slides over your image, and you're calculating the area of overlap between that kernel and that image. And so if you have a very large value, if your area is large, that means you have a lot of overlap. And if it's small, then you don't have a lot of overlap there. And it's the metric for, you can think about it as like a metric for similarity. So if they are the exact same, you'll have a very high peak because they're exactly the same. Let me look at the next question. And so there are a couple ways to extract the weights. And you'll go through this in the hands-on lab. And someone had asked before about extracting weight in the network without changing source files, and you'll go through that exercise in the lab. So these images here are very similar to what you're going to do in the lab, except in the hands-on lab, except you're going to do this in Python. And if you've looked at any of the Caffe examples, you'll notice that all the features in there are very similar to what you would see in some of the Caffe examples. I did use that to help me come up with the lab, just because I thought it was important to look at features. And you'll notice too, like in addition to that, you'll compare features between two different input images, so you can see how similar responses are or how dissimilar responses are in some cases. Yet the neural network is able to identify categories accurately in some cases. So if you don't want to use Python though, if you don't want to use Python, take a look at the examples. There's also a feature extractor binary that's created. So when you build Caffe, a series of things will be created. You'll have a Caffe binary that you can use for training and deciding what GPU you want to train on and so forth. But there will be a couple other binaries in there, like making your mean image for your main input data, and you'll see one in there for feature extraction, and you can use that. And there's also an example. I'd have to look up the link, but if you go on the Caffe website, you'll see a whole list of examples there, and you'll see there's a feature extraction example in there that you can do as well. So someone had also, well, let me do this next one before I get to that. So other functions that you'll learn about in the lab is, another function you'll learn about is pooling. So I think sometimes people will ask about pooling and what that is, or sometimes you'll see it called subsampling even. And this is a layer parameter or a layer type. And when I think about pooling, you can think about it as, one way to think about it is a way to reduce your dimensionality but still maintain information. So if you look at the area that I've highlighted, the large images might activate, the larger image set is my activations, and then the smaller one in blue, those are my activations after I get my pooling. And so you see where I've highlighted in white, you have, here are my activations, and you can see where I have, where I got a good response relative to my kernel. I had a lot of similarity there. And then if you go to the same spot where I show in blue, where I have the pooling result, you'll see that the response is still very similar. Even though my input has reduced, even though that data has reduced, I still have that information, that similarity information about how well that data, that portion of my input data related to that kernel, even though I've reduced the input size. Also, there's a couple things you can do. So pooling, you'll decide a window, and it can be 3 by 3, or it could be 5 by 5 even, and then you'll have a 5 by 5 window, so you'll take 5 pixels by 5 pixels, or in this case on this slide you'll see 3 by 3, and now you'll decide how you want to reduce it. So I'll take that window and I'll say, I only want that, I'll reduce that, and I want the maximum value, or I want the average value of that window, and you'll be able to decide that. In your lab, we have the maximum value set. I think when I tried doing the average, and you should play with it yourself, but I feel like at least I remember the average, when I tried with the average, I didn't get, the accuracy wasn't as good. I think I was in the lower 60% accuracy when I did average, but then when I tried doing the max value, I got better performance. So there's another thing that you can play with as well that you might find really interesting. In the previous slide, I talked about having your inputs and outputs and your name. So for pooling, the type is pooling. I give it a name. In this case, it's pool 1. And the bottom is, that's going to be what goes into this layer. And in this case, it's com1. So maybe the output from the convolutional layer, the text that you saw on the previous slide, the output from that will be pushed through this pooling layer. And then when it comes out, it'll be titled pool 1 as a label. So when you think about configuring your network and your text file, that's one thing you want to try and keep track of. I feel like when I'm making modifications to my neural networks, when I'm tweaking things and modifying things, that seems to be one thing that gives me the most hiccups, is that I didn't keep really good track of what my ins and outs were on my network. So maybe I accidentally had data coming into pooling, and I also had data coming into my convolution 1, and now things aren't going well for me. Also, sometimes if you do a copy and paste, maybe you copied pooling twice, and now you've got 2 pooling layers, except one pooling layer is with convolution 2 and convolution 1. So you kind of have to just, at least for me, those are 2 things I have to watch for myself when I'm editing my own network. And let me talk about this. So there's also another layer type that that you'll use in this example, and one is using the inner product. And so when you use the inner product, you'll define the number of outputs, and one way to think of this is your sometimes called your fully connected layer, and you'll define how many outputs. And when the data that comes out of this, you could think of it as a linear array defined by those number of outputs. And part of this exercise this lab will have you insert inner products into your neural network and use that to help you improve performance. And then we'll also have you compare inner product values between two different images. So what you'll do is you'll have your trained network, and then you'll have an image of a cat and a dog, and then you'll look at the features of the feature responses. You'll push both those images through the trained network that you created after you make these modifications, and then you'll look at the feature responses and compare them. And in some cases, you'll see similar responses. Other cases, you'll see dissimilar responses. But in the end, the network is still able to identify the cat and the dog correctly. And then at the end, you'll also go through a classification example. So one thing that I get asked a lot about often is, okay, what's the best way to classify a lot of images, and how can I do that? And so at the end of the lesson, there's just a really simple Python loop where you'll read in a text file that's provided, and it has images, and it's passing images on the host machine. And it'll read in those images and push them through the neural network and then give you a classification. So it's really simple. It's just something made to help you get started, and you're definitely welcome to optimize it and improve it. And if you wanted to do the C++ route, check out to get more speed, definitely check out the Caffe examples, because they also have a classification example to help people get started there too. So that's just one thing, another thing to think about when you're going through this whole process. I thought I'd take a moment to just talk about the Caffe examples too. So I know when people are just getting started, we're always asking each other a lot of questions, and the whole thing with the hands-on lab and even having this is to help people get started. Unfortunately, I only have this one Q&A session, and you only had time with John Barker last week, and you're probably going to have a lot more questions. So like many of us do when we start exploring these networks. So I thought I'd just have one slide that talks about some of the examples on the Caffe website. And there's an example for training the ImageNet data set. So they don't have the ImageNet data set available. You would have to get that through ImageNet and download that yourself. And you can download a URL list and download images yourself. But the training with ImageNet example, it's really helpful. I used it, even though I didn't have all the ImageNet data, I used it to help me learn how to train for the first time with Caffe with my own data set. And I thought that was really helpful. There's also a Lynette and a CFAR10 tutorial. Fine-tuning. There's a fine-tuning example. And there's a really interesting fine-tuning example where you take a pre-trained ImageNet network and you do a style recognition. You fine-tune it for styles, and that's a really interesting thing. So you can use that for other things. So you could take a pre-trained network, and you can take a pre-trained network that you created yourself, or a Caffe one that somebody that you work with created, or even download one on Caffe Model Zoo website where they have some pre-trained networks for people to download and use. And then you could fine-tune on that network. So maybe you have data that is like data for maybe some type of landscape recognition or scene recognition. And you could just grab a pre-trained network, a GoogleNet pre-trained network or an AlexNet pre-trained network, and do fine-tuning with that for your scene recognition or whatever type of data set that you have. They have a lot of examples. They have feature extraction. They even have a web demo. So you can, it'll go through a web demo, and it's through Python. You launch this web demo as a web server application, and the example is really easy to follow. It shows you where the paths are to your trained network, where you would have your labels text file that relates your categories for your training data and so forth, and then your mean image that you'll create and things like that. And then you launch it, and then you can do classification. So if you're doing it on your local machine, you would just launch it through your web browser. I used the web demo on my Jetson TK1, and I just had it running on my home network. And so I had just connected to the web demo from my laptop and so did my classification on the Jetson TK1 through my own router at home. So you can do really simple things like that. The examples are relatively easy to help you get started, and then help you kind of explore all the features and all the capabilities within Caffe and all the different things you can do. If you have questions, so there are a lot of ways to reach out and get help. There's a link on the deep learning website where it'll show you where you can post questions, whether it's for Digits, Caffe, Torch, or Theano. But I also posted a link here specifically for the Caffe users group, and where you can post different questions about using Caffe if you're having issues. What's also really nice about the Caffe users group is it's a Google group, and I often will search. If I have a problem or I'm interested in doing something, then I'll go onto the Google user group and I'll just Google to see if somebody else has had a similar issue to what I've had. Or maybe they just want to do something that maybe I just want to do something that I haven't been able to do before and I'm not sure how to do it. I'll see if someone else has done it. And so I find it really handy. Someone has asked before about doing different input types. So there have been a couple questions about Caffe being image focused, and they just wanted to know, okay, well, can I input other data? And you can do rectangular images. So one thing I've seen is some people have asked about signals in the past, and I do some Digits work, and Digits is built on top of Caffe. And one thing we've talked to people about and other users about is if you can input your data. So if you have a signal or some other type of data type that is one-dimensional, if it can be represented as a linear array, maybe a one-dimensional array, 1 by 100, then you could ingest it and you can push it through Caffe in that way, and that's one way to think about it. One thing to keep in mind is that, so when I usually use Caffe, I have rectangular images, I have square images. So if you want to do something rectangular, make sure to have that listed in your trained val file and then your deploy file when you want to do classification. So when you look at your prototype files, it will specify and state you need to tell Caffe what your input dimensions are. So if your input dimensions, so if you're not doing a square image, even if you're doing a rectangular image, maybe 300 by 1500 or something, or if you've got some signal data or some type of data that can be represented as a linear array, then you would just need to modify that in there and make sure you have that the network knows that the input data is 1 by whatever, 1 by 250 or 1 by 100. And if you don't, so if you do it in your train val, if you're training and validation file, and then you forget to do it in your deploy file, the deploy file I only use for classification after my train network. So usually what will happen is if I forget to make changes to my deploy file, Caffe will error out on me in abort. And that's usually the first place I look is my deploy file to see if when I made modifications to my training file, I forgot to make changes to my deploy file. And that's usually my culprit. There were a couple other questions. Someone had also asked about whether or they could use different versions of the Caffe model file with these versions of Caffe. So if you look online, there's Caffe is changing rapidly. It seems to always be changing. And then if you look at all the forks, then you'll see there are a lot of versions of Caffe out there. So for the most part, I haven't found any issues with using using old Caffe models with the current version of Caffe. That may change in the future, but for now I haven't had any issues with that. You can also do things with, so let's say you trained on Caffe, you have a pre-trained model, and now maybe you want to do classification using digits, and digits uses Caffe. There are ways to do that too. And there's some posts online about that as well, how you could do that. So another question was compatibility with other frameworks. Someone asked about sharing train models. I'm not sure about Theano. For the most part, I would say anything can be done, but whether or not it's easy or whether or not they have like a module out there, I don't know. But I did see a module for Torch. So if you go on the Torch page, and I'll just post this in the broadcast to all so you guys have it. Give me just 1 second. So if you go to, so you have a pre-trained model with Caffe, or maybe you just downloaded a pre-trained model on Model Zoo and you want to do training with it and you want to use Torch, go onto the Torch installation wiki on GitHub and you'll see information on there on using Caffe, and then there's a module for a load Caffe module. I haven't tested it myself, but it's on there, so presumably it works. I suspect it does. It's something that I should test out this week. But definitely check that out. I know that a lot of people use Torch, and so I suspect that it works. If you have hiccups or if you have issues, just remember you can always reach out to the Caffe users group. They have a huge user base, wide user base. There are a lot of users that respond to questions. But Torch has one too. So if you have a Torch issue and you're trying to load Caffe in, you could reach out to the Torch Google user group too as well. I get a lot of questions about, is there a way to find out how many layers we should use? So for me, it's an experimental process. I sort of add layers I just add layers, and I'll increase outputs and modify things. One thing I really like to do when getting started, is just start with a standard network that's out there that someone's used, and I usually lean towards AlexNet. AlexNet is a network that was used institution, and he had won in 2012 with his convolutional network configuration. And I usually start with that one. It has 5 convolutional layers and then 2 fully connected layers at the end. And I'll usually start with that one just to see if things are going, if I can train well with that network. And if I don't train well with it, sometimes I'll try another network, or sometimes I'll just try tinkering with some of the parameters. If I'm not learning at all, there's a couple things that could be happening. One is like overfitting, or it's just not learning very quickly. It could be something with my learning rate. So those are a couple things to think about. So when it comes to how many layers should I use, it depends on your data, it depends on what you're trying to do. But I usually just start with a pre-existing network out there. And there are a couple out there. there's also a lot of literature out there for network configurations that you can use to help get you started. And they've been proven to be pretty successful, pretty effective. And just as a thought, when I first started using like AlexNet or looking at these frameworks, at first I didn't really know or wasn't sure if AlexNet really made sense for me, because the first time I started training or trying to experiment, I had like 30,000 images from like 4 different categories, and I thought, well, maybe AlexNet is too complicated because AlexNet used 1.2 million images from 1,000 different object categories. Maybe it doesn't make sense. But it turns out that for the most part, AlexNet works pretty well for me. There have been a couple cases where I've used like CFAR, which in this hands-on lab you'll use CFAR, and CFAR has 3 convolutional layers, and so you'll start with that in this hands-on lab. There are a couple times when I've talked to some people and they've done some experiments where they're trying to do like car no car or a pool no pool, like binary type of classification project, and they've been pretty effective, pretty successful with CFAR. So you just have to kind of experiment and see what makes sense for you and what will give you the best results for your data. And if you are on a multi-GPU machine, or even if you just have a small data set, it won't take long to perform different trainings. But if you have a multi-GPU machine, you could just, it's really easy to take your data set and you could do trainings in parallel. So all you would do is, let me go to the command so you guys can see it, for those of you. I believe this is it. So one thing to think about, and this is what your command will look like, where you'll have your Caffe, train, you'll define your solver file, and the solver file will have your learning rate and momentum and iterations and so forth, and then you'll decide what GPU you want to use. So if you have 2 GPUs, it's really easy to just push one training to one GPU and push one training to another one. Let me see if we have another question. Another thing that's come up before has been multi-GPU training or cluster training. And I know there is a branch with NVIDIA that does multi-GPU training right now that you could check out and you can experiment with if you're interested in doing that. And it's very similar to this. The command looks just like this, except at the end here you'll append your line. It'll say GPUs with an S, and then you'll have an equal sign. And then you'll just say 1, 0, 1, 2, 3 for all the GPUs you want to use. So there is that branch, and I'd have to check to see if it has merged into the master branch. If it hasn't merged into the master branch, feel free to go to NVIDIA's site, NVIDIA's GitHub site to download it, and I'll paste it in right now so that you have it. So somebody had also asked about doing like cluster, using Caffe with clusters, and you should probably, I saw some information on their GitHub about it, and but you'd have to check up, you'd have to follow up with them and see what the status is and if they're making where they are with that and things that what the progress is, how that request is going. Let me post that NVIDIA Caffe branch. So you could use that NVIDIA Caffe branch for multi-GPU training. I had another question about doing 3D volumes as your input. And so there's a couple things. You can think of convolutions with 3D volumes if you think about it with respect to color channels and it's already happening. But there has been a discussion that's already being done. However, there has been a discussion for the explicit 3D convolution, and there is a pull request for it. So that I saw before, and you would have to check and follow up with them on the status of that. And let me post that right here so people have that too. And you have to follow up with that and then engage with, even just engaging with the Caffe folks about it and other users. Another thing to think about, so using Caffe and using Caffe for internode stuff and this type of stuff, things that aren't supported right now, one thing that you can do, because it's open source, is you could do a lot of things if you're interested in. You could do some things yourself. And when I think about doing things in a cluster, like in our cluster at NVIDIA, we have a Caffe module in our clusters, and so we have Caffe running, and so it's really easy for me to just log on to one of our nodes and then do multi-GPU programming too, as well with Caffe. And I use it just like I would any other module within our cluster for the most part. So somebody had also asked about, is it true that the weights and activations are stored in single precision floating point format? And yes, that's true for now. If you had a special need, if you had a special need for that, one thing you can do is there's just a really big open source community. I know I've said this a couple of times, but that's one way to engage with folks about it, about your needs, and talk to people, because you may not be the only one who's interested in doing other things, or you may not be the only one who has special formatting needs, or format needs that are just different than what's out there. So in some cases, it may just be a functionality that hasn't been well documented. So maybe it's there and nobody's using it right now. In other cases, maybe the feature isn't there, and all you have to do is like engage with the community and see what the status is. Maybe it won't be a big deal to update that, or maybe it won't be a big deal to update it, or maybe it's something that you could update and engage with the Caffe folks, or if you're using another framework, the other framework folks about too. So someone had also asked about, does Caffe and digits support more than one digit set box? So Caffe is working with digits on the digit set box, so all the digit set boxes have that. Currently with digits 2, the Caffe branch that's supported with digits 2 does multi-GPU programming. One thing to keep in mind, though, is I posted the link earlier with multi-GPU Caffe training, is that there's a GitHub link for it. So you could, if you have your own machine, multi-GPU training machine, or maybe you're on AWS, or if you're on SoftLayer, you could have this on your own. You can have this on your own machine as well. Someone had also asked if does Caffe work with CUDA 7.5, and we are supporting all the major frameworks such as Caffe. So the 7.5 production version hasn't been released yet, but generally speaking, when new versions are released, they should be supporting the major frameworks. So that's one thing to keep in mind as you move forward. And yes, the Titan X is supported. So when you think about using the GPU for Caffe or for doing your training, one thing to think about is just using CUDA, and CUDA is supported on all the GPUs. One thing to keep in mind when you're using cuDNN is that you need CUDA compute capability 3.0 or greater. Or you need a compute capability 3.0 or greater if you want to use cuDNN. And cuDNN is a library that I've talked about before, but for those of you who maybe don't know, it's a library that it's free. You can download it. It's separate from CUDA, but it's separate from your CUDA install. But it's a library focused on deep neural networks, and it caters to its whole goal is to squeeze out extra performance on the GPU, and it's got functions called specifically for deep neural networks, convolutional neural networks. One interesting thing about cuDNN 3 is version 3, I believe we just started supporting Fourier transforms. So those of you that are familiar with convolutions, you're probably really aware of its relationship to the Fourier transform. And with Cudanon version 1 and 2, we didn't have that in there, and now we do for Cudanon version 3. So I mentioned digits a couple times. So if you use I mentioned digits a couple times because I use it often, and it works with Caffe. So if you were interested in maybe downloading an all-encompassing Getting Started package, you could download digits from our developer site, and it will come with Caffe and scripts for installing all the precompiled binary, all the dependencies and so forth. And it'll build Caffe for you when you run through that whole exercise, and then you'll have digits as well. But when you download it, you'll download it, and it'll say you'll have a directory like digits, and you'll change into that directory, and you'll see a subdirectory 1 for digits and all of digits files, and then you'll see a directory for Caffe, and then Caffe will be there as well. And so that's one easy way. If you feel like maybe that would be easier for you to just have one download, then that's one thing you could do as well. One thing to keep in mind is that downloader is only for on Bluetooth 14 right now, so you'd have to make some changes if you were on a different version, different operating system. But there are instructions for other operating systems as well. So that's all I've got for today to talk to you guys about. I just wanted to thank you guys for your time and for your participation, and thank you guys for participating. And I just wanted to remind you of all the classes before I let you all go. I talked about it before, but I just want to, oh, someone asked for the digits download link. Hold on, sorry. So I have the, so for those of you interested, we've got other classes, and I hope you guys can participate. And then one thing I really like about this class series is that it's an introductory series, and it gives you the opportunity to kind of get yourself familiar with deep learning and some of the things that some of the activity that's going on, and then explore some of the frameworks. So I work closely with John Barker on the Caffe and the digits exercise, and the whole goal there was to try and just give you a taster and get you familiar with ways you can tweak your network so that you can get started and do some really really interesting stuff that I'd love to hear about when you guys get started. And hopefully you can participate in the next one, in the next class piano, and the next class torch. And if you have questions, definitely post them in that class and then follow up with us during the office hours. And then also the hands-on labs. So definitely check out the hands-on labs. You don't need a GPU to use them. And so it's one easy way to kind of, even for yourself, test out the GPU and test out the power of a compare a GPU to a CPU and compare performance gains. One thing I definitely like to do is compare performance between different CPUs and even different GPUs and different systems and stuff like that. It's really fun and interesting. That on top of all the parameters you can change and all the different data sets out there, things can get really interesting. And then you start looking at all the publications and things. Just it's a lot of fun. So thanks a lot, and I'll let you guys have a nice day, and definitely check out our hands-on labs and reach out to the user community if you have questions or send us emails as well.